Hello and welcome to Math Albertua today. Today we want to learn how to solve simultaneous linear equations using a method called Cramer's rule. Okay, so we have equations here. This is equation 1, equation 2. They said we should solve these two equations, simultaneous linear equations with two equations with two unknown using Cramer's rule. They know that we can use elimination method to solve the equations, or we can use substitution method, or we can use the idea of graph. And then the point of intersection of the two lines will not be the solution to the two equations. But they said use Cramer's rule. Okay, Cramer's rule simply means it's a method of using determinants. A method of using determinant to solve simultaneous linear equations. So please stay put as we enjoy this lesson. Okay, so look at the equations. Look at the equations. What we're going to do now is, I want to show you something. Let me manipulate this. Equation 1 can be written as 2x plus 1y equal 13. And equation 2 is still the same, 3x minus 2y equal negative 5. Okay? Now, we are going to make use of determinants. So collect the coefficient of x and y in equation 1 to form the first rule of the matrix. So you collect the first coefficient here is 2. Collect it. So we have 2. The coefficient of y here is 1. You write it. Go to the next equation. The coefficient of x here is 3. You write it under rule 2 of the matrix. The coefficient of y in the second equation is negative 2. You have it like this. So we are now going to find determinant of this matrix just by collecting the coefficient of x and y in equation 1 to form rule 1, coefficient of x and y in equation 2 to form rule 2. We go ahead and find the determinant of this matrix. We have got it. So let's call the determinant of this matrix we want to find, and let's call it delta. Now, how do you find the determinant of this matrix? Remember, you go from left to right first. Multiply this way. If you do that, you're going to say 2 bracket what? 2 bracket negative 2. 2 bracket negative 2 is 2 multiplied by minus 2. Then you put a minus. Then you can now multiply to the ordinary diagonal. Please, left to right first before right to left. Okay, we are multiplying 3 times 1. Okay, now if you multiply very well, you're going to have 2 bracket. This means 2 times minus 2. You have minus 4. Minus 3 times 1 is minus 3. Then minus 3 minus 4 minus 3 is a negative 7. Alright? Borrow 4, you have not paid back. Borrow 3, you have not paid back. So altogether you'll be owing 7. So that means that the determinant here represented by delta is actually minus 7. Okay? We still need to find 2 and go through the determinant 2 more times. Okay? What do we do then? This time around, we are going to say delta 1 this time. Now, what we're going to do now is, where we just found our delta now, we're going to delete this first column, please. Now, okay, delta 1, let me write like this. Let me write 2, 1, 3 minus 2. I'll make you understand it very well. Now, this is what you have, but for you to find delta 1, you will now delete this first column of the matrix. Take it away, and then you go back to the equation and use this right-hand side of the equation to complete that place. So 13 and minus 5, you collect the same. You have 13, here you have minus 5. Alright, so find determinant again and see how it goes. Alright, so go from left to right. You're going to have 13 bracket what? A negative 2. That's 13 times minus 2. Then the minus there for determinant. Then we now have what? A negative 5 multiplied by what? By 1. Now let's go. So 13 multiplied by negative 2. That will give us a negative 26. Okay? This minus sign should wait for now. A negative 5 times 1, you get a negative 5. And then, let's go. This is equal to, so negative 26. Negative 26. Let's go. So minus into the other minus inside the bracket is going to become plus, because minus times minus is plus. Then the 5 will come out. Now, minus 26 plus what? Minus 26 plus 5 means you were owing 26. Now you now have 5 of such of the things you are owing. Pay back the 5, you will still be owing 21. All right, so this one is going to give you negative 21. Okay, so what gave us this negative 21 is actually the second determinant, which is called delta 1. Now, lastly, we are going to say delta 2. Now, copy back that what we were having before. We were having 3, 1, 3. That's 2, 1. Let's write that first. We have 2, 1, and then 3 minus 2. So we have 3 minus 2. But for you to find delta 2, you need to delete the second column this time around. When we wanted to find delta 1, we deleted the first column. And then we now replace the constant of the equation 1 and equation 2. We put it vertically to represent that column. So now for you to find delta 2, we are now deleting the second column and replacing that same 13 and minus 5. We now put it in the second column and still go ahead and find determinant of the matrix. Let's go from left to right. Let's go. So we have 2 multiplied by negative 5 minus, now go this way, you have 3 into what? Sorry. You have 3 multiplied by what? 13. All right. Let's go. So 2 multiplied by negative 5 will give us negative 10. And then negative 3 multiplied by 13. That will give us a negative 39. Yes. Negative 39. Let's go on. Okay. Now, negative 10, negative 39 means borrow 10, you have not returned. And then borrow another 39, you will be owing a 49. Okay. So here is negative 49. Now, look at what you need to do now. Look at what you need to do now. All right. So we're going to say x is now equal to delta 1 divided by the value of the general delta. For you to find the value of y, you're going to say delta 2, you found out, and divide by the general delta. Now, the question is, what is delta 1? Delta 1 is a negative 21 divided by the general delta should be 7. Yes. Okay, negative 7. General delta is a negative 7. So we'll return to it. For delta 2, for y, delta 2 is a negative 49. So we have negative 49 divided by negative 7. Over here, if you come, minus cancel minus, 21 divided by 7 is equal to 3. Let me use another color to just write the answer. Is equal to 3 here. Here, minus cancel minus also, 49 divided by 7, you get a 7. Okay? So we can boldly say now that, that when x is equal to 3 and y is equal to 7, these two answers will satisfy the equation. You can go ahead and use them to test run equation 1. When you are done, still use the same value of x is equal to what? 3, y is equal to 7. To see test equation 2 is going to work perfectly because this is the correct pair of answer that is correct for the two equations. All right, thank you very much for your patience, your attention, and participation. I want to now quickly give you something that you will do for me now. Please, when you are done, do not forget to what? To write the answer in the comment section. Do not forget to write the answer in the comment section. Okay? All right, so I solved your classwork instead. So you go ahead and do the example I had in mind. So go ahead and do the example I had in mind. I ended up solving your classwork for you. So please go ahead and do the example I had in mind as your classwork. When you are done, please tell me the value of x and the value of y in the comment section. Thank you very, very much. Please do well to like this video, to share this video, to follow if you are here to do so, and to subscribe if this is your first time of coming across my video. Thank you very, very much. I'm delighted. Thank you. I'm grateful.